The design structure method really operates, the core of it is operating on an interaction matrix, because you're really interested in the core DNA of the program. That is, what actions each task is responsible for, who does it supply information to, and when, and on the other side, what information does it need to be able to complete its set of activities. So here we see a typical interaction matrix where the columns are supplying information and the rows need information, and we can see in looking down column B that B is supplying information to C, F, G, J and K, and that D requires information or inputs or resources from E, F and L. So that basically in each situation you can see what inputs come to a particular activity and what outputs it supplies, and therefore its position in the overall web of interactions that is a development program. The serial tasks, we've got coupled or dependency types, coupling types, and there are basically three. Now, serial tasks are the first of the category, and they're the simple A leads to B, that is, A must be completed before B can be started, and they're sequential tasks. Parallel tasks are really independent tasks, that is, that A or B can be started at any time without affecting each other. And then we get coupled or cross-coupled tasks, which are chicken and egg tasks, and these tasks are actually the ones that cause us the most problem and make up the risk profile typically of a project. And here A needs information from B to get started, and B needs information from A to get started, and of consequence you wind up frozen in time until somebody provides the necessary inputs, or B, you just substitute a best guess for one of them and move on. The location of the coupling types is fairly interesting. There's a natural boundary in the interaction map, which is the diagonal that runs through it, and that is actually where each task essentially maps back onto itself, 1 to 1, 4 to 4, 10 to 10, 16 to 16, as the case is running down that diagonal. Now below the diagonal are the independent and dependent tasks. These are the tasks that typically build the classic CPM. There are no real feedback cycles in a CPM, albeit we've figured out tricks for putting them in there, but intrinsically they're not there, and so you have just independent and dependent tasks. So the domain of a CPM lies under the diagonal. This is where a perfect project plan would fit, because every piece of information you require is immediately above you. It's in a perfect information cascade from the top left to the bottom right, and in this domain you're a fairly happy customer. Above the diagonal is the domain of feedback tasks or cross-coupled tasks, chicken and eggs, and we can see that if we look, say for instance, at row 4 and column 6, we can see that 3 needs information from 6. But of course, if our time flow is run 1 through 16, that's the order of tasks executed, that 3 is looking for information well before 6 will have it ready. So we're really seeing there a feedback from 6 in time coming back to, and that's the red feedback path, back from 6 or B back to A. It's going back up the timeline, and as such it's a point of risk, because we're really starting the project, or running, if we're running down that timeline, we're starting the project without full information, and so there's an element of risk associated with that element at 3 and 6. The interesting part of this is that under diagonal is fairly low risk. It's a classic forward CPM type program with all information available when you need it. and we've got our smiley little face there. We're very happy in that domain. It's relatively safe. Above the diagonal is a bad place to be, and the further you're out from the diagonal, the worse it is. Because basically, if we were to consider projects like Task 1, Projected New Technologies, and we had a dependency just for instance on 16, we wouldn't know whether or not we had made the correct assumptions until we had actually got to 16 and confirmed it. And if in fact we were right, then terrific, we've missed the bullet. But if we happen to be wrong, then we've got a pretty large rework cycle, because if in fact 16 was really wrong and it impacted 1, we might have to rework some or all of this project. And that means that rework loop just ran up from 16 on the bottom horizontal axis, up the outside to 16, and across the top to 1. And it says that every activity inside that envelope, which is the whole project, is potentially part of a rework cycle. So the point where the node is, the square that is formed below it is essentially the area of the envelope of possible rework.